In this video, we're going to look at gradients. So a gradient or slope of a line is the measure of how steep it is. So let's look at the first one. The first one is a positive gradient because it goes from left to right, up. The second one is a negative gradient because from left to right, it goes down. This one is a zero gradient. It's flat, so it doesn't have any steepness at all. And this gradient, we would say, is undefined. Okay, you can't define the steepness of this line. Okay, so let's just have a look at how we work out the gradient. The gradient of a line is usually determined by how much it goes up, the rise, divided by the horizontal distance, which is the run. Alright, so in the purple box is the formula. So let's just have a look at some basic gradients here. I'm just going to work out what the gradient of this, and I'm going to do this by counting the squares. So we need to look at the rise between the start and the end of the line. You don't always have to do the start and the end of the line on a graph, as long as you have two coordinates. But obviously it's easy for me to use the start and the end of the line here. So we can see that assuming each square represents one unit, this goes up 2 and the unit across is 4. So the gradient, which I'll just write as m because we use the letter m for gradient, is 2 divided by 4, which is a half. So the gradient is 1/2. Let's look at this one. This is not such a steep line as that one, so we expect a lesser number. The rise in this case is 1 unit and the run in this case is 4 units. So gradient is 1/4. So it's a quarter. Over to this one. This one is going down from left to right, so we understand that the rise between the start of the line and the end of the line is a negative rise. In fact, we say it goes down -3, and the run is 2. So we say the gradient of this line is -3/2, which is -1.5. Now let's go on to look at some graphs where we have some coordinates. Obviously this is a continuous line here. We obviously have the x-axis, which should always be labelled, and the y-axis here. So we're actually looking at the difference between 2 points on the graph. So I'm going to choose this point here and this point here. So it cuts through those exact points. Again, let's look at the rise between those 2 points. So the rise between those 2 points is 4, and the run between those 2 points is 2. So the gradient of this is 4 divided by 2, which is 2. Oops. Now let's look, oops, hang on, let me write that, m equals 2. Let's go over and look at this line here. Okay, so we can recognise that this line is from left to right is going down. I'm going to pick this point here on the line and this point here on the line. So remember, it must be 2 points that you can get the exact values of. And let's look at the rise between those 2 points. The rise is -1 because it's going down, and the run is 4. So the gradient of this is -1 divided by 4. Now, there is another formula that we use for the gradient in terms of coordinates. If we allow the first coordinate to be x1, y1 on a graph, and the second coordinate to be x2, y2, we can then formulate an equation that says that the gradient is the difference in the y direction, y2 take away y1, divided by the difference in the x direction, which is x2 take away x1. And you can see I've put a diagram which clearly shows that this is the first coordinate and this is the second coordinate. Alright, so let's do an example. Find the gradient of the line passing through the coordinates 3, -2 and 6, 4. So what you need to recognise is that this, because reading it from left to right, is the first coordinate. So I will allow 3 to be x1 and -2 to be y1. So there's our first coordinate. And this one is our second coordinate. So 6 is x2 and 4 is y2. Now it's just a simple case of substituting those values into the formula that we wrote up earlier, which was y2 minus y1. So I'm going to do 4 minus, and it's a negative, so it's -2, divided by x2 minus x1, so 6 minus 3. Now let's simplify that. That becomes 4 plus 2. Okay, divided by obviously 6 minus 3. So we've got the gradient to be 6 divided by 3, which simplifies to be 2. So our gradient is 2.